Okay, so now we're ready to talk about the last of Newton's laws, and that's Newton's third law. And it states that for every force that's exerted on an object, that object also exerts a force with equal magnitude and opposite direction on whatever caused that original force. So, for example, if you exert a force on a wall by pushing on it, that wall exerts a force back on you that has an equal magnitude. These pairs of forces are called Newton's third law pairs. You only ever draw one of these pairs on a single free body diagram, because the free body diagram only has forces that are exerted on that object in it. So in this example, if you draw a free body diagram of the wall, you would only include the force of the person on the wall, not the other force. And if you draw a free body diagram of the person, you would only include the force of the wall on that person. One thing we can do to make some calculations easier is to define a system. And in physics, a system is just a collection of objects, basically. And depending on what kind of problem you're trying to solve, you might want to include certain objects in your system. So when it comes to forces, you want to include objects that all move together. For example, you might include a car with all of the people inside it as a system. Or you might make the system just a single object or person. And this lets us define kind of two broad categories of forces. One is the internal forces, and these are forces that are exerted within a system. For example, if you're sitting in a car and you push on the door, then that push is an internal force because it's happening within the system. These internal forces are ignored for any Newton's law calculations, so you would not include those forces when you're calculating Newton's second law, for example. And then there are also external forces, where an external force is a force that comes from outside of the system, and these are the forces that you do use in your calculations.